This video is the second part of the chapter 4 visualization. So the first thing I want to do is just quickly touch on what we already did and just add a little bit to it. We were talking about visualizing a single variable on Tuesday. And the first thing we talked about is the categorical variable. And for that, in these notes, which I will put on Brightspace, I just wanted to guide you to where we did that. So we did it within the index match file that's on Brightspace, and we used the variable education. And if you recall what that looked like, we created a frequency and a relative frequency table. We formatted, and then we used the bar chart or column or bar chart option 1. And we were making these, we selected in the first case, this amount of data. And for the relative frequency, we selected the, using the command or control key, we selected disjoint columns, and we made a relative frequency table from that. So I wanted to just quickly remind you of what we did. We made, using a pivot table, for education, we did a frequency and a relative frequency calculations, if you recall. And then we copied that and pasted it using paste special so that these were just numbers. And then by selecting certain columns in this, we made either the frequency table or we made the, this is holding down the control or command key. We made two separate columns of data that then we use to make this relative frequency table. So one of the things that I did not do is show you how to do a pie chart, but that's because we covered it in 210, but also it's very straightforward from what we have done already. So let me just quickly show you that. If I select these two disjoint pieces of data, I can go up here in the insert ribbon to the charts group, and I can select the pie chart. So now I have this relative frequency, and I can add maybe the, maybe I'll add data labels. And so maybe here we'll just change this to relative frequency of patients, education level. And if you notice, it's a little hard to read, so we could click on those, come up here to the Format tab, and in the text fill, we can choose the white one. Sometimes that makes things look a little better. The other thing that we can do, and you can play around with this for a long time and you know, kind of entertain yourself and go down rabbit holes of like different ways you may want this to look. So here's another option. You know, the other thing we can do is change the chart type and maybe do a 3-dimensional version of this. So it'd look kind of like that. So anyway, I'll stop there. All right. The next thing we talked about was visualizing a single numerical variable. And this is where we talked about doing a histogram. We did this with the heights data that was just here. That was again from Tuesday. And this data is, we played around with how many bins, if you recall, that's in the video. And I did not review doing a box plot because that was part of the task 1, part 1 cleaning, which we've reviewed various times, numerous times. Okay, then we moved on and talked about the relationship between two variables and visualizing that. We started with two categorical variables. So in here, we created contingency tables and what are called empirical distribution of probability tables. So I thought I'd just review that real quick. And we did this within index match. So this is where we made a contingency table using race and education. And in both this and the previous one, we rearranged the order, recall. We did that. And then I showed you how we could take, currently it's showing the probability but we can change this right at any time by going over here to values and under count of race to value field setting. And we can show this as no calculation if we want just the counts. So right now this was reverting back to these counts down here. And if you recall, what we did was, again, we copied and paste special so that we could make graphs and they would not change and they would be based on, if we change the pivot table, we don't want the graph to change and we want to have more control over our graphs. So I showed you side by side. Let me close this down. So we talked about side by side bar charts. We talked about stacked bar charts. I wanted to remind you that when we talked about the empirical distribution or probability, it's the probability that the cells. So we took each one of these cells and divided by the grand total of 400. If we add up across the rows, this 8% is 30 divided by 400 and so on. So we call this the empirical distribution or the probability table. And if you recall back from your statistics course, this was the probability of the joint distribution of the cell. So it's the probability of race and education for that level. So for example, if you randomly select any patient from this doctor's office, the probability that they had some college and were Hispanic is 8%, because that's the proportion that they are of the 31 out of 400 is out of all the patients at this office. Okay, then we moved on and I showed you how to make these 100% stacked bar charts that kind of give you some idea of a distribution within a category. And what I wanted to remind you of now that we've made them, we used the pivot table to make this, and we simply went to the values field settings button and we showed the value as, and if we wanted it to be by the percentage of the row total, we selected it this way. And we copied that down and changed the decimals on the percent. But what I wanted to remind you of is that this is the percent, this is a conditional probability. So what we're seeing in these percents is the probability of that education level given the race. So for example, when I look at this, let's say I take again this 30%, a second ago that represented 8% of the overall, if I randomly pick any patient. Now, if I select a Hispanic patient, if I look at the subset of Hispanics, all the patients at this doctor's office, and I say, well, if I randomly select one of those, what's the probability that their education levels, their highest level is that they've had some college? And we see here that it shows up as 30%. So we call that a conditional probability because it's given that you already know what comes after the line. So we already know that we're Hispanic, that we're picking a Hispanic, and then we just want to know the probability. If we know that that's a for sure, what's the probability that they've had some college? Okay, and then we can flip this around, and now you see it's the probability of race given the education. So now if we want to come down here and let's see, I want to pick one that the number changes. This is just coincidentally, that is a coincidence that it's the same number. Let's go up just to the first one. So let's say I say, okay, I'm going to subset all the patients to those who've had the highest level of education being a high school degree. If I randomly select one of them, what is the probability that they're American Indian from this doctor's office? And that's 7%. So that's the proportion of the patients that are American Indian and have given that they're the highest educational level is high school. And we created stacked bar charts in both cases using the data from each of these. So I'm just reviewing again, we made side-by-side bar charts, we made stacked bar charts, we made 100% stacked bar charts with the variation of doing a conditional probability. So that's everything we just finished reviewing. Then we talked about visualizing the relationship between two numerical variables. And for that, we looked again at scatter plots. And if you recall, we went to the correlations.xlsx file from our Brightspace, and we looked at age and salary. But first I had you kind of just pick the first 200 records because it was too much. So let's just look at that. All right, so this is just the first 200 records. If I scroll down, you'll see it stops at row 201. And if you recall, we just selected age, and then we selected salary by holding the control or command key down. We went to insert, came down here to scatter plot, created that scatter plot, and then we added a trend line, and then I formatted it to be red. And that's where we're at. That's as far as we got on Tuesday. So today I'm going to talk about another way to visualize the relationship between two variables, and that's a line chart. And this is what we do if one of the variables is time, and the second is a repeated measure on the same entity. So it doesn't really make sense to measure someone's height, like Susie's height on, January 1st of 1999, and Sam's height at a different, July 3rd of 2005 or something. Like, that doesn't make any sense. What we want is the same entity. So we'd want to see Susie's height over time and how that changes. So in order to do that, I grabbed some data that's in the data module in Brightspace. It's called the Chapter 4 Visualizations Part 2 Excel file. And in there, there's a tab for the Dow Jones Industrial Average _ 2019. And that represents the first 6 months of data for the Dow Jones Industrial Average. So I want to show you that data. All right, so if we wanted to do a line chart of this data, we're going to select the data. Here, this data is very simple. It just simply has the date and the Dow Jones Industrial Average. And so we're going to select those two, and we go up here to insert. And in the middle, just below the column, is the line chart. And we'll just select the very first one. You can also select the one that has, this one that shows you the individual dots with markers. But I think that can be a little bit busy. Sometimes when you're just looking for a trend, a simple line is sufficient. So here is what we got from Excel. One of the things that is important to realize is that it is sort of framing the y-axis using some algorithm on the minimum and maximum and giving you a little bit more on that. This is where I was talking about that sometimes you can be too zoomed in your range and think there's a big trend going on when there may or may not be. So it looks like around between May and June, there was a drop in the Dow Jones Industrial Average, and you could possibly become very alarmed over something like that. So first of all, let's just make sure we put the right titles in here. In first half of 2019, and let's put, so we can add more tick marks down here if we wanted. You just have to format those. So right now it's in the units, and the major is 1 month. So you can change this to days, which would be maybe a little too much. But if you wanted, maybe you want to do it kind of by week. I didn't see week as an option in here. So we can just pick 7 days, gives you a little bit more granularity. We can also choose under add chart element or one of these, if you're on Windows, the plus screen, and we can add, we have to not have the axis selected. In the grid lines, we can go over here to primary, major, vertical, and that will give you a little bit more granularity if you, some additional grid lines if you want to use those to see what's going on. Okay. But what I wanted to show you is that we can take the same data and create a line chart again. And I just want to show you how different things look. And I'm not going to go through playing on with the grid lines and all that again. I just wanted to show you that if I select the y-axis and right click and go to format, oops, accidentally unselected it. So select the y-axis, format axis. So down here, over here on the right, it'll say the minimum, and it kind of gives you this based on an auto, says auto, and that's because it's doing an internal calculation to kind of frame that for you. But if we set that to 0, we can see a very different overall pattern. It doesn't look that this drop from May to June is as severe. In general, things look like they're trending slowly upward. So it would change perhaps how you interpret this data and how a reader of your chart interprets it, depending on the axis. And this is where I was saying that sometimes there can be unintended or sometimes purposeful changes in the way you would view data just by changing the axis, and you have to be very transparent and very clear about this. Now, when it comes to the Dow Jones Industrial Average, someone who is an economics or financial expert would maybe be able to give us a better idea of what is a change that has an economic impact on the nation. And so at that point, you would maybe say, well, geez, this was like we're going up here from around 2,600, and then by June 5th, we're below 2,500. So that's like 1,000-point drop. That actually is significant and will impact global economies and whatnot, and drives decision making. So perhaps the original scale makes sense, or maybe it's something in between. So that, again, is where analytics always needs to be interleaved very closely, working very closely with subject matter experts. The next thing I want to talk about is visualizing the relationship between two variables when one is numerical and the other one is categorical. So there's a couple different ways to do this. One is 2 box plots or multiple box plots, but the first one that I want to show you is an interleaved histogram. So we're going to look at that tech sales reps, the first 200 records, and we're going to look at sex and salary. We are going to create a pivot table, and we're going to use female. And actually what you can do is actually select all the data in between. Actually, but let me make sure I don't add those blanks at the bottom. So let's say we want to get all this data, and we're not sure what are all the things we're going to do with it. So let's just go ahead and select it all. We're going to insert a pivot table, and we'll say okay. So in our new worksheet, let's call this tech sales pivot. We're going to create we're going to by hand create a histogram that's going to name, and we're going to be able to split it between males and females. So what we want in that histogram is the data on the salary. And obviously right now it has every individual salary from our data. And we don't want that. So we're going to just click somewhere on the values, and then up in the pivot table analyze tab, find where it says group. So we're going to group the selection, and it's going to find the minimum for us and the maximum, and it's going to suggest a grouping. Generally, this isn't a bad place to start. So I'm just going to say, okay. And it looks like it's giving me, somewhere, I haven't counted it, but maybe around 12 groups, which is fine. The unfortunate thing is it does drop the dollar signs on this. Right, now that I have this grouping, I'm going to take a female and bring it over to columns. And now I have male is 0, female is 1. And now I'm going to take the salary, and you can use any one of these because this is clean data, because we're just counting how many times there's data in one of these buckets. We're going to say count of salary. And now we have a breakdown of this data. Now let's copy this so that we can make a interleaved, what's called an interleaved histogram. So let's copy this down and let's change some of the stuff in here so we know that this is salary and that we are talking about sex here, and that this 0 represents male, and 1 represents female. And if you select multiple columns, they will all end up, and you resize them, they'll end up being all the same size. So if you find your widest one and kind of can set that up like that, you'll end up having nice equal widths. That's kind of one way to do that. So I'm going to put a big box around this. I'm going to give the top a line underneath the names of the variables. I'm going to merge and center the sex. Put another line between the bottom category and the grand totals. Okay, and maybe also we'll add another line here. A right border line here and another one here. Okay, again, you can keep going on this stuff for a while. I'm just gonna center that. Okay, well, now that I have my data pulled out, I can use the salary male female breakdown data. I select this and I'm going to go up to insert, and I'm going to in here select the side-by-side bar chart. So now that I have this is actually the beginning of a interleaved distribution, because you see we have the bars for male and female. We just need to make it look like a histogram, which, if you remember, is what one of the rules of histograms is, that you don't have any gaps between your bars. And that was actually forced in the grouping back up here in the pivot table. So we're fine there. We just need to make it look good. So I'm going to format the data series. So I selected a bar chart. And over here in the one that has like a bar, I'm going to set the gap width to 0 and the overlap to 0. And once I do that, we have now a interleaved histogram, which allows us to see the distribution of a numerical variable salary broken down between male and female. And again, this is just a categorical variable, has 2 values. I could do this with more, but it starts to be hard to visualize. So this is really a technique that works best for a categorical variable that's binary or has no more than 3. If not, it's kind of visually difficult to see if there's a difference in the distributions. So if we look at this, we see that there just is more tech sales reps that are male, because the histogram bars are higher. But the distribution looks roughly equivalent. I mean, we'd have to do more analysis on that, but it doesn't look like there's a big difference between the salaries for the males and the females. And you can kind of see that if you imagine where the general shape of the 2 distributions are. Okay, well, let's give this title a more accurate title. So we're going to say distribution of salary. Okay. And then these numbers could be anything, so it's probably a good idea to give that axis, at least the primary axis title, a name. So we'll say salary. And since it's not giving us dollars, it won't format to dollars. We'll put that in the units of the axis title. So if we wanted to look at data that's numerical, and we had a categorical that was more than just two categories, we would want to do something called an approach where we would maybe look at multiple box plots. So if we go to the tech sales data, the way we would do this is we would have to divide our data up into males and female data. So we're going to make sure we have in the data tab the filter selected. Let's go ahead and first of all get the female data. So we're going to subset this data to female. Well, just to keep ourselves clear, let's go ahead and select all this data. And we're going to put that in, oops, let's copy that. And we're going to put that all that data in a new blank sheet. So we're going to paste special here. Okay, now if you notice the sales rep number ID goes 137. So, and female is all 1. All right, so that's kind of a way to double check that you did that right. And then let's go back here and select the male data. And we're going to copy that data over. And we'll put it next to this. And you'll see that you have different data now. Side by side, we've broken up our data into the female and the male data. And we really should rename this. So tech sales, maybe by sex. Okay, so now we can do a box plot. We're going to take and if you recall, we were looking at salary. So we want to, maybe we want to go back and make sure we put that in as dollars. That's fine. Okay. So we can select the salary and go to insert and come down here and select the box plot, which we've done before when we were cleaning data. So for this, we can hit, let's go ahead and we'll just work with it in this worksheet. So I'm just going to move it over here to the side. So what I would like to do is add the salaries from the males in their own box plot. So to do that, I'm going to select the chart. I'm going to go up here to chart design and select data. And in here, I'm going to add, and the series name, I'm going to call it male salaries. And for the series values, I'm going to select this column of data and I'll say, okay. And for that first one, I'm going to edit it. And I'm going to just call this one female salaries. I'll format this data series because I'm going to unclick show inner points. I do want the outlier points. I don't need to show the mean marker. Well, I guess it's okay. Let's scroll over so you can see what I just did. Okay. So we have that value and then we have this value. So what I'm trying to play with now is getting it to let me put a legend on here. So let's say the title is distribution of salaries by sex. Okay. I'm seeing a strange value of blank down here. So perhaps I need to edit this data. I'm going to edit this data. I'm going to just manually type this in here, see if this works. From W2 to W201. Which might not be right. because there's less males than 200, 126. Okay. So sometimes, depending on how your processor is overloaded, like mine, I think right now is overloaded because of the Zoom. Was having some, it's not catching up with me. All right. So what I told you was this side-by-side box plot is what you would use to build if you were doing some kind of distribution with more, where the categorical had more than two values. So you can of course do the two side-by-side box plots instead of interleaved distributions if you'd like. And you can sometimes see things a little differently. So here we can see that the median for females is lower. The range is tighter, but the average, which is what that little X is in there, is a little bit lower. And we certainly see that the whiskers and the outliers for the males goes much higher. So in order to create multiple box plots using a categorical variable. So we want to do a numerical variable and a categorical variable that has more than two categories. And I was telling you that you don't really want to do that in interleaved histogram if you have more than 2 or 3 categories. So if you do have more, a common technique is to do multiple side-by-side box plots. So I need to show you how you would do that. The way you would do that is, let's say we take our sales data, and I started this already, but let me select all here. So here's our sales data, and we want to get the salaries for each personality. So what we have to do is we have to build that. So I added another sheet here, and I'm going to put each one of those categories. And what I'm doing is I'm going to copy paste special the salaries for each one of those. So let's rename this field. I'm going to call it salary by personality. Maybe I should say salaries by personality. Let me say, keep that one plural and save a little, singular, keep it a little more space. So what I was doing here every time is I just selected each one of these. So the last one left to do is Sentinel. You go through one at a time, you select it, and then you're going to get copy over all your data for that category. And you're basically putting salary data under the category name. So I'm going to copy this, come over here, and on this last one, I'm going to paste special and remind myself that that one was called Sentinel. So this is Sentinel. Right. So I took all my salary data and I just divided it up and created 4 columns of data. And now what I want to do is create a box plot for each one of these to see if there's a difference. I mean, certainly there's way more data in the Explorer, but we want to actually see the distribution of the data. So the first thing I'm going to do is I'm going to select the analyst data. I'm going to go to Insert and Box Plot. So this is something that you should be very comfortable doing at this point. We've done it to determine if we had outliers in our data. Now in here, what I want to do is I'm going to select data, and here I've selected analyst. Now I'm going to add another field name to that. I'm going to select diplomat. And then for the series values, I'm going to select the diplomat data. And I'll say OK. And then I'll say I'm going to, and you can do this all in one step, but I'm just going to show you. If I say OK, I now get this data like this. Now the default for this is to put these dots in here. We're going to have to come in here and format the data series and uncheck show inner points. For those of you who are in on a Mac, you may or may not get this easily. You may have to come up here and go to format and then choose the series diplomat, and hopefully you'll see where you can uncheck show inner points. Then we're going to do the same thing again, and I'll do the next two all in one step. So I'm going to select I'm going to go to my chart design. I'm going to select data. I'm going to add the Explorer, and then I'm going to click on the series values. So we're adding a new series of data, and I'm going to select that and say OK. And then I'm going to add the last one. The last one is called Sentinel, and the series values for that are here. So then I'll say OK, and then I'll be done, and I'll say OK. Now there's a couple things that I don't like about this. So one of the things that I can do, and I can spend a lot of time on this, but let's just say we say salaries, salary distributions by personality types. Okay, then the other thing I don't like is over here on the axes, it looks like we're gonna use the right arrow, and I'm gonna remove the primary horizontal because it wants to give me a 1 there. And then the other thing that it appears to me is missing is a legend. So we'll add the legend so we know what we're talking about. And then I can play around with this. I would like to make the gap between these. I don't know if it's going to let me, how easy that's going to be, but I would like to make the gap bigger. I don't know if it will. Let's try to make that 200. Nope. That was going the opposite direction. So like some of this stuff you just have to play with to get it to look more normal. Okay. And the salary, we can select all this data and format it as salary data with dollars, and that will automatically fix that. Okay, we have to manually go in one at a time and remove those inner points. It wants to make that the default. There may be a way to modify the default. But I haven't done that in a long time. Okay, so there's how you make side-by-side box plots, and those can be very useful. You have to take your data and divvy it up for each of the category types and build this like alternative data table, and then use that to build a box plot for each one. Okay. So we saw now how to do that multiple plots with the personality and salary broken down. The next thing we want to talk about is visualizing the relationship between more than two variables. So the first thing that we often want to do is look at a scatter plot where we have another variable that is a categorical. And we want to add different colors based on the value of the categorical. This generally only works if you only have 2 or 3 values for your categorical categories. If not, it starts to get too messy. But I wanted to go ahead and show you how we do this. So let's go back and look at that data we set up when we broke down all our data by sex. So we had our tech sales data, and we have the data for the females, and then we had the data for the males, and we made the side-by-side box plots. So in this case, what we're going to do is we're going to make a scatter plot, and it's a little bit of a similar idea. We're going to look at age by salary. So selecting those two and inserting a scatter plot. This is the females data. So we have this data that looks like this, and I can move it on over so we don't have it sitting right on top of our data. We'll put it here. And then the next thing that we can do is overlay this with another series of data. So we're going to do the same thing we just got done doing, in that we start our chart, and then we're going to go up here and select data. And in here, we're going to add another series of data. So this series of data, we can call it male salaries. And So we're going to put the X values here. So here we're going to pick the age for the males. And we have to be careful on the Y values. You have to delete this equals 1 stuff. If not, it gives you an error. So we're going to pick the salaries now for the males, and we'll say OK. And for the previous series, let's edit that. So we're going to edit that, and I'm just going to come in here and I'm going to call this female. We'll hit OK. And OK again. All right, so now we have our scatter plot with 2 colors, blue and orange, and we probably would like to know which is which. So let's add a legend in there. And you can decide where you want to put this legend. So maybe you want to put it at the bottom. That's fine. Let's give this chart a title. So we're going to call this salary. Sometimes you end up selecting it, you got to delete it. Salaries by sex of these tech sales reps. Okay, so we now see a little more granularity than what we had originally seen back up here in the distribution. And I'm not sure why we have the 0 here. We're having a 0 showing up. I'm not sure where that's coming from. Oh, I think I might know. Let's select the graph and go into chart design, select data. Let me look at that data. So the orange is the male series. I'm going to edit that. And I think it's because it wants to go do all the data here. So let's just delete that and select it by actual bottom of the data, so we don't go beyond what's there. Let's try this. I think that's going to clean it up. And it did. Okay. So that is helpful. And now what we want to do, if you'd like, is you can go in here and add a linear trend line. And what's nice about this, it's going to let you decide which one you want to do. I don't think you can do both. So you have to do one at a time. And then we can add it again. And there's different options we can do here. Okay. So we can select it and format it. Maybe. So format trend line. And I'm going to come over to the paint can, and I'm going to select this to be a solid line. Let's go with a solid line. See if that helps. Oh, sorry. And it's a dash type. I'm going to pick solid. And since this is the male line, I'm going to choose orange. I'm having a hard time finding the exact one. Let's go to the select orange. Okay. And then for the blue line, let's come over here, select that one and format that trend line. Same idea, go to the paintbrush. Let's select, you can select the solid line. I believe that might be doing something else, but okay, that's fine. Dash type solid, and let's make this color blue. So we can see that Excel is smart enough to keep the trend line within the range of data, which is what you'd want to do. It looks like the salaries by age on the males is pretty flat. The salary by age on the females does appear to increase as they get older. And one thing that looks very suspicious to me as I'm looking at this is that I'm seeing values out here for age, so let's add our axes titles. So this is salary. And this over here is age. So something looks wrong, right? What happened with age? Why is age? If we get our data and we hit a filter on it, we can see what we got in here. We go from 21 to 65, and we're seeing something different in this data. So something happened here. So let's go back and fix that. Okay, so let's look what happened here. So the age values are somehow getting messed up too. So let's be a little more careful. And I think we're getting some kind of random stuff in here. So let's go ahead and select the age starting for the males by selecting the top and bottom of our data. So it appears that Excel can handle doing a lot of fancy stuff for us if it's the first scatter plot, but when we add a second series of data, it appears like we need to be a little bit more careful about what we specify. All right, so now we're actually zoomed in a little bit and we actually can see there is a difference in the trend lines, which we would expect from the box plot distribution to have seen that. Okay. So now that we've looked at that, the next thing that we want to consider is if you have 3 numerical variables. And for that, a good technique is to use a bubble plot. And for that, I want to show you that using the car price data that's in the Chapter 4 Visualizations Part 2 Excel file. So let's go over to that data. And it looks like this. You have price, the age of the car, and the mileage. So when you're deciding to use a bubble plot, what is a good idea is that one of your numerical variables doesn't have that many values to it. It's discrete. So really this is in a sense 2 continuous numerical variables and 1 discrete those are good candidates for bubble plots. You can get around this if you have 3 continuous by taking, let's say age was, down to the minute or something. And basically doing what this age has already done, which is binning it. So you can bin one of your numerical variables and then use that for the size of the bubbles. Now, this is a weird one in the sense that we start it backwards. We start it by not selecting data. We start by putting in a blank template, if you will. So I'm going to go to Insert, to the charts, come down to Bubble Chart. So now that I've selected this bubble chart kind of blank, so we're going to go into the Select Data, and we're going to add a series of data. The series name, I'm going to call it price, and then I'm going to put in the X values. I want that to be the mileage. And the Y values is the price of the cars. And then the size of the bubble is going to be related to the age. And then I'll say okay and okay. And we can see here that we have a relationship between the price of the car and the mileage. So let's give this a little bit of some titles. So we'll say this is the price. It's obvious it's in dollars because it has dollar symbols, and the axis titles, we're going to say the mileage. So we can see here that this is the price by miles and age of cars. If you look in here, you can select any one of these and you can kind of see what's going on. So this is the 77,241 miles, and it's sold for 12,988. and it's 5 years old. So we do expect, of course, there to be a relationship between mileage and age. So we see that here as the bubbles are getting bigger in general, not always, not for all of these cars. And we can, by the way, make this bigger and kind of see more what's going on a little bit. Okay, so that's how you do a bubble plot. Well, let's see what the legend gives us. Sometimes the legends in Excel aren't so great. Yeah, it's not maybe going to allow us to do this. I think it's only going to give us the legend for this series. You could add another bubble plot in here for other data. Maybe this is sedans and you have another one for trucks and another one for, luxury vehicles, or, economy cars, luxury vehicles, collectors. You might see some differences in the trends. Okay. Another type of graph that often shows up is if you have one variable of the two numerical variables is time, and another one is categorical. So you want to, in this case, create 2 line charts on one graph is frequently useful. So let me show you that with the India-China data. And the India-China data in that visualizations data set is the population in millions from 1960 to 2017. So the way we're going to do this is we're going to select the data that we want to put in the line chart, ignoring the time variable. And we're going to go to Insert Line Chart. And then what we're going to do is go into Select Data. If you are in a Mac, you would go to Format, and you're going to go to Horizontal Category Axis. And then you'll select the cells that correspond with that. For those of you in a Windows, we would go to Select Data. On the right-hand side, this is the Horizontal Category Axis labels. So we're going to select that, and we're going to, from here, select the data all the way from A2 to A59, and we'll hit OK. And then what that's going to do is it's going to give us that x-axis with the corresponding years. So we're able to see the trend in India and China in population since 1960 to 2017. So here we could say populations. And for the axes titles, it might be a good idea to put this in as population. Oops, somehow selected population. And then we'll say millions. And then for the axis title down here, we'll put year. All right, so now we've completed that graph. Let me go ahead and move it up towards the top of the page, as you don't usually want to have your graphs somewhere down below where no one can see them. The next kind of visualization we want to do is if you have 2 categorical variables and 1 numerical. And for this, we use something called a heat map. I'm going to show you how to do this using the t-shirts data. That's again in that chapter 4 visualizations, visualizations part 2 file. And just to make it kind of easier in a sense to understand a contingency table, a heat map is really just a contingency table with shading. So because of that, we need to first of all set it up, and we're going to do that. Here's a t-shirts data. We're going to go ahead and do that by getting a pivot table. So let's go ahead and get a pivot table, insert pivot table. And this time I'm just going to put it right next to this so we can kind of work on this all in one place. Oops, I need to state that it's going to go here. Okay, so for this contingency table, let's say we want to look at the two categoricals, so size and color. So let's put size down on the rows. And oh, we accidentally picked up all the data. So let's go to select data. Sorry. Change data source. And so I'm going to go and get the rectangle of data. Okay. That should have gotten rid of the blanks, yes. So we have large, medium, small, extra large, and extra small. So again, we have to reorder this, don't we? So we're going to go, there are some tricks besides what I showed you about dragging that we can do. For example, extra small, we can move to the beginning. So that takes care of that one. Then some of these we can just simply drag. Again, finding that 4-pointed arrow, holding the shift key down and dragging it. And I don't even think you need the shift key actually. Yep, you can just click and hold down your cursor button. All right, so now we put these in order, and let's add color to the columns. And we don't care about the order of color, I don't think. So what we want to know, right, is the more frequent quantities. And so in order to do that, so what we're going to do in here actually is we want the quantity. Each one of these is a transaction. So I think if we put the quantity in here, let's see if I can drag the quantity down here. I actually do want the sum of quantity because that's how many were purchased and that transaction of that size and color. So if I add them up, this is helpful to me in that it kind of helps me figure out which sizes and colors are more popular or less popular. And now that we have this set up, it might not be a bad idea to convert all this to the probability or the proportion of our data that each cell represents. So if you recall, we go to the value field settings and we're going to go show value as, and in this case, we do want the percentage of the grand total. So we'll put in the percentage of the grand total. We can reduce the number of decimals here, decimal places here. Maybe we want to center this. Okay, so now that we have that, let's go ahead and copy this and paste special. And we're going to put in here the size, and we'll put up here the color. And I'm going to get rid of this sum one and just go ahead and quickly format this. And we've seen this formatting before. Again, there's nothing inherently right or wrong about different ways of formatting as long as everything is easily understood and visible. Okay, so let's say we have a little table like this, and now what we would like to do is turn it into a heat map. So I would like, first of all, I'm going to try to make my columns all the same width. That's going to visually help that look better as a heat map. So one of the things is Excel is sort of helpful for creating a heat map. Actually, before I do that, I'm going to give this a vertical line here as well. Okay, so when we select these inside values, what we want to know is, we want to change this into a heat map. Maybe I will add a decimal here just to give it a little more granularity. And what we want to do is go into this conditional formatting, and we can come down here, color scales. And you can choose which color scale you want. If having a higher percentage is good, maybe you want the one that has red, yellow, green. So going from lowest, sorry, that one's going the other way. So we want the highest to be the higher number. So this is the green, white, red color scale. You can try using different ones. So by selecting this, I can quickly identify that the medium greens are my highest seller, or this company's highest seller, and that the medium purples are the overall lowest. So we're able to kind of highlight those colors. You can play around with some of these different conditional formatting options. Again, usually people think of green as good. So if you want something to be highlighted, usually red is considered bad or stop. So, you want to play around with this to find one you like. This one kind of has all the intermediate ones. This is the green, yellow, red color scale. Very traditional in a sense for a heat map. So we go from the red hot, not good, all the way up to the great dark green, which is great. And in between, we have these different shades that kind of indicate to us which are the higher proportion sales in our contingency table. Okay, and that's how you make a heat map. And that is the last of the visualization techniques that we're going to go over. That's probably most of them. There's some other weird things out there, but these are the basic ones.